All right. Hey, everyone. My name is Victor Mata. This is Josh Stone. We're both pen testers for PSC. We are a part of the Security Labs team. Here's our information. We both have blogs. I'll admit that Josh updates more regularly than I do, but we are both committed to sharing information. Here's our picture, just in case if you forget our face. So let's talk about the philosophy, how we're here, and the philosophy behind our Snarf application. It was about maybe over a year ago that Josh and I were kind of tossing around ideas on about how we can improve existing attacks, the attacks that we see on everyday pen tests, on our assessments, and how we can actually capitalize on those that are kind of limited. And so one of those attacks is the SMB relay attack. So just really out of show of hands, is anyone here familiar with the SMB relay attack? Okay, so a few of you. Yeah, a good bit of you. Better than our last one. So going back. So with the SMB relay attack, there are a few limitations there that really make it ineffective as far as the potential. We recognize that there's an uncapped potential with the SMB relay attack, and we really wanted to capitalize on it. We believe as pen testers, it's in our DNA that we want to exceed the boundaries, push the envelope. Really, on every assessment we go on, we always think about how can we make this more efficient. And so really that's where it all began. And for the past, over the year, we really steadily developed off and on trying to get this attack more effective and how we can optimize it. So just kind of a quick and dirty intro on SMB relay attack. I'll explain how exactly it works. And if you could look at the diagram here, we'll have number one is convincing your victim to authenticate to the attacker. This can actually be accomplished several ways. Usually the top 5 ways is we have NBNS, LMNR poisoning or spoofing, ARP poisoning, DNS, DHCP spoofing, poisoning, what have you not. It doesn't really matter how you get there, it's just as long as you get there. And really what we want is to harvest or to receive authentication requests from our victim. Number 2 is to initiate, once we receive authentication requests, we want to go ahead and initiate a new connection to our target. Once that new connection has been established, we want to go ahead and relay the authentication process between the victim and the target and back and forth until the authentication is complete. Once the authentication is complete, we'll go ahead and terminate the connection. Usually, if you're familiar with SMB relay implementations out there, you'll notice that from the client side, it just says access denied, and then they move on. But on our side, on step 5, we'll go ahead and have our end product, which is the authenticated session. So there are, like I said previously, there are limitations out there with the SMB relay attack, and the limitations are out there so that it really makes it not as an effective solution for actually accomplishing compromising the network. And I'll show you why. First off, there's MSO 8068, which was released in November 2008. This attack really, prior to this patch being released, attackers could essentially relay the credentials back to the victim and own the victim and own the authenticating victim. It was really a free-for-all. Then after that, after the patch was released, hackers had to adapt, sort of, and now the current implementation is relaying those credentials to another target server. The second biggest caveat, or really the limitation here, is what I call the one-hitter-quitter effect. And I'll explain. The one-hitter-quitter effect is really an assumption that the victim that you are targeting, or the victim possesses administrative privileges to your server, or to your target server. Now, the reason why it's assumption, because if you're executing a payload or you're trying to execute a command on the target, you need administrative privileges to accomplish that. So let's say, for instance, you're sitting on the network and you're doing your ARP poisoning attack, or you're doing your LMNR NBNS spoofing attack, and you're sitting there trying to get all these authentication requests. Really, you're essentially praying to the Active Directory gods to send you a domain admin account. Otherwise, the compromise really will be ineffective. The other solution to execute the SMB relay attack is to harvest the credentials, and then from there you can crack them with Hashcat or John if you want. So like I said before, we really wanted to optimize the SMB relay attack. Josh and I sat down and we created a shopping list, if you will, shopping list of all the features we wanted to implement and improve on the existing attack. How can we make this better? How can I make this attack so that it's more profitable to us? And we came up with several lists. First off, we have introduced other SMB features. So the SMB is not just limited to executing payloads. It's not just limited to executing commands. There's actually more things in Samba or SMB that you can do other than just execute. There's other things out there. We also wanted to add discovery and enumeration. Discovery, enumeration, information gathering, those are critical components in pen testing. Really, so without discovery and enumeration, we wanted to add that into our process. There's so many things that we can gain from just from the low and informational data that we can actually use in our pen tests. The next big one is perform multiple SMB operations per session. And that's a really big one because currently, right now, if you want to execute a payload, or if you want to execute multiple payloads, you would have to have multiple incoming requests or authentication requests. What we really wanted was to have one authentication session and use multiple operations on that one session. The last one is, or the second last one is support existing tools. We also wanted to be the ability to use SMB client, to use RPC client, to use Metasploit, to use the Samba net commands, to use psexec, nmap, NSE scripts. We wanted to be able to not just limit ourselves to either our own built-in application, but we wanted you to have the ability to actually inject any other SMB tool that you want to use. And the last one is an interface for centralized management. When you have all these incoming connections coming to you, we wanted the ability to actually manage all those sessions and be able to choose from these sessions as you want. And our application will actually maintain those sessions as the assessment continues. So here is an illustration of what we really wanted out of the SMB attack. Here's an optimized attack. So if you see, there is an authenticated session at the bottom. One authenticated session. We wanted to be able to perform all these operations on one session. We wanted to be able to enumerate users, enumerate shares, download, upload files, stop list, and create services, access registry, and deploy a payload if you wanted to. Prior to our application, or the existing implementation of SMB relay attack, you would have to have a separate authentication attempt for each and every one of these operations. Now, we actually wanted to be able to keep one session and perform multiple operations on that one session. That way, if you do not have an unprivileged account, you can actually perform other operations other than just having a failed attempt. As a pen tester, we wanted to capitalize on every opportunity out there, not just leave it all, or not just throw it away if it's not a domain admin account.
So everybody familiar with the internals for SMB? Probably watched it in Wireshark a little bit, at least. This project, we learned a great deal about SMB. A couple things we just wanted to cover. This is not a deep intro to SMB. It's just to say that every SMB session follows a certain consistent process. First, there's going to be a TCP connection that gets established, usually 445. We're doing everything on 445. But then after that, the two systems negotiate what kind of SMB they're going to speak, because there are tons of them. It was invented in the 80s. And so there are many, many dialects that may be selected. And then after that, a session setup occurs. That's where authentication happens. And then you have any number of transactions which happen within tree connect messages within SMB. So really what happens is I get my TCP connection in, I authenticate, and then every time you list files on a share, and then every time you copy a file or execute something, that's a different, potentially a different tree connect, but certainly different transactions, all within one TCP connection. Right, so we authenticate at the beginning and then have multiple transactions, and that's really the attribute of SMB that lets us do what we'll get into in a sec. Also notice right at the bottom, we've got SMB log off. So there are actually a couple different ways that SMB sessions terminate, but the proper way is for the client or the server to send an SMB log off message saying that this session is done. So if you got that firmly in your head, I think the next chart should help a little bit. This is what we're going to do. If we go back here, the SMB log off is what terminates the session. So this shows you what what our tool does. And we'll also get this into more of a general approach. There are a lot of protocols where you can do the exact same thing. The client authenticates, and we're relaying this session. The client does some transactions. It could be one transaction, it could be 1,000, we don't really care. When the client is done and it logs off, we just don't deliver the log off. And we keep the session up. We let the client disappear, and we hang on to that authenticated session. And then we enter our own loop where we open a listener on the local host, and you can connect any SMB tool into that, and it'll continue to use that same session. It was authenticated once, and we do any number of transactions. And we do just a little bit of effort here and there to make sure that the tools you're connecting in think they're talking to a normal SMB server, but they're not actually going to authenticate. They're just going to get passed directly on into that connection. And so it turns out we can have any number of inbound connections, we can have any number of sessions we're maintaining, and we can swap out any of those authenticated sessions that we possess and connect our tools into them. So that's what you're going to see in the demo. If you look on the left there, we just have, remember there are tons of different ways that you can get to this situation. A lot of man-in-the-middle attacks, a lot of name poisoning attacks, and these still happen all the time. So demo time. And hopefully, am I still mirroring? Yes, cool. So, I have a Linux machine here. It's just a basic Kali tools written in Node. So if you install Node, then you can just grab it from our GitHub. We'll get to that in a sec. We have two boxes. Here's Alice. It's Alice 7 because I also have an Alice XP, but it seemed like 7 would be better for demo. And then I've got a Bob 7. They're both members of a domain. We can look at, I'm logged in at the Josh.o domain, and my username is Josh. So first of all, we have to establish a successful man-in-the-middle or name poisoning scenario. I've got an ARP poisoning running here in the background. So we've got these two machines routing through my box. Prerequisite for man-in-the-middle. For the name poisoning, we'll talk a little bit about what's different in that situation. But anyway, so the tool itself is called Snarf, and it does a couple things. One, it binds to your IP address, and anything that comes in, it's going to service that connection. We use IP tables to do some of the rewriting for connections that are coming through. So I'll just run this and I'll have it bind to my IP. There are a few other options. We'll get into what those are about in a minute. But when Snarf starts, it creates a chain in IP tables called Snarf. And then it tells you, hey, in order for this to work, you have to run this IP tables rule. The reason we have that in there right now, at least, is because you may not necessarily want immediately everything coming through. You may want to modify that rule. If you're on a humongous subnet with lots of SMB, you may only want to single out certain systems or apply other rules before you start servicing these connections. And if I... so I've got, and hopefully that's probably a terrible spot to have it on the screen. So here, come on, touchpad. So the Snarf chain, all it does is it logs the connection coming in. That lets us identify what its source IP and port is and what its destination IP and port is, so we know what to connect to. We can talk more about that later if you have questions about how that really works. But here we're just taking anything on port 445 and we're sending it over to the Snarf chain, and that's going to end up DNATing it locally so it goes into our tool, etc. So that's how the network glue works. So once this is running, all I need to do is have some session come through my routing. So from Alice, we'll just do something real simple. I don't have to do the IP. Bob 7, we'll just do $C because I am admin. So their drive Z is now connected. So, and I'll show you in a minute, but this is a fully functional connection. I'm not doing anything evil yet. It's still quite innocuous. But over here we can see that Snarf gives us a little bit of output. So we can see, for example, we got a connection from this IP, We looked at the kernel log, we found out where it's going, so we have a DB hit. We're going to make a new connection out. It's trying to communicate with SMB2, and we hate SMB2 because all our tools don't use it. So we're going to scrub SMB2 so it won't negotiate that. It'll downgrade it to 1. And then we can see just the transaction traffic through that SMB session. But as cool as that is, we give you a little bit more, an easier way to look at things. We have a local web-based interface where you can see all the connections that you have. Actually, we can do LS7. Can't type when lots of people are watching. There we go. So then if I hop back, we'll see another one over here. And this will fill up over time as we poison names or get more connections routing through us. And we can see information. Now, I'll warn you, every other time I run this, it'll use Kerberos or they'll use NTLM to authenticate. I can't really control that. If it comes through with NTLM, then we know what the username is, and that would show in these fields here. And also, we'll give you the hash. It's unknown here because Kerberos, we just don't get to see that stuff. But if it's NTLM, we'll give you exactly the line you need to pop it into Hashcat or something like that to try to crack it if you want to. But let's see, and we'll see if it's been 82 seconds since this connection last communicated. Eventually, that connection will finish. And even if I do this, let's see. If I terminate that, it'll be a little while before that connection actually dies, so for now I'll just expire it. It turns out you can expire a connection, and usually Windows won't really care too much because Windows expects these to tear down and have to reinitiate them all the time. But once we have that connection released, so that client no longer has that drive mapping. I do my net use, we see no entries in the list. And I have some other things I can do now. I can choose this one, and actually I'll go ahead and expire that. So if we choose this, this is where we start the local listener. So now I have something listening on 127.0.0.1 on 445. So we can start doing some interesting things. I'll just go away. Well, you probably should see the output. So if I do an SMB client, and I specify my username is just B and my password is B. Remember, I was logged in as Josh, the Josh account in the Josh O domain. So this is definitely not the right username and password, but it doesn't matter. I can go to 127.0.0.1 and I just pick the $C share. You can see here up at the top, we've got a hacker tool that we have now authenticated, and we see that the hacker speaks SMB and the server responds, and we're now communicating in that old session that has been given up by the client. And this works interactively. I can do anything that I want in here, and I can exit, and I can start it again, and I can continue using this. And I can do things like SMB exec, right? Not SMB exec, WinExe. Everybody's watching. There, something like that. So there you can see I had another connection in from a hacker tool, and here we're running as the Josh account. So what if, as we're going along, I'm having a really fun pen test and I decide the Josh account, though interesting, in this case it is actually a domain admin, but what if I do another connection here to Bob7, $C, services, service1, because I have excellent passwords in my target domain. So now if we hop over, oh cool, I did NTLM. So now we have a third connection here from the services account, and we can see a little bit of information about that system. As you have these running through, you get a few tens or hundreds of them, and it's really helpful to have some of this data. There's our hash or our NTLM v2 negotiation. If we want to try to crack that, you can pop that directly into Hashcat. But then now if I exit here, and then I expire that, and then choose that, then I can connect again, and who am I? I'm services now, I'm not Josh. So I can hop back and forth between these connections, get as many as we want, and use them and reuse them. And what it means is, if these aren't local admins or domain admins, it's okay, because I can still look at the shares, I can still get information from the registry, I can get installed software manifest maybe from a couple different techniques. So you can end up doing quite a bit with this, and it makes this a much more useful thing than to just kind of hope it happens and we get our interpreter. Yeah, so let's see. With that, we'll go back to non-demo. So we'll go through this kind of quickly. There are a few things that we have to do to make it work. One is sessions die pretty often. Cool. And so we have to set some SMB options. If you want to talk about that, let us know. We can talk to you about it afterwards. But these sessions stay around for a while. I've had them last up to like 16 hours, which a normal SMB connection will not do that. So we do a little bit of magic in there to make that work. And then, yeah, we got 6 minutes. So other protocols, any protocol that is probably unencrypted, supports multiple transactions in one connection, and authenticates at the beginning, and doesn't have any message authentication will be susceptible to this. We have working code for MySQL. It does the same thing. There are a lot of protocols that will work like this. It just happens we're doing it with SMB right now because it's really helpful. To mitigate it, you want to turn on SMB signing. That's perfect. I was at a place last week that had SMB signing turned on, and so I got lots and lots of sessions everywhere, and they were absolutely useless to me. Other protocols, SLS, TLS, SSL, etc., certainly help. We've got a few things like a round robin feature we did very recently where you give it a list of IPs, and every inbound connection, it'll send it to a different server. So you get enough of these things coming through, you'll have hundreds of sessions, and you just keep going until you get a machine where that user is local admin, and you win. You can get this on our GitHub, github.com/purpleteam/snarf. Works on Kali. You have to install Node. And with that, questions. I think we've got 4 minutes, right? Cool. All right. No questions?
What's the maximum number of connections you've seen in the tool so far?
The most I've seen was about 200. It is actually usable at 200. This was a few weeks ago.
It's scenarios, common real world scenarios.
Yeah, the tool has worked really well in 3 compromises that I've had in the last month or so. And it just turns out you get one account that might be regularly LLM and Ring or something like that. Every 3 minutes you get 3 sessions. If we're round robining that, that means after an hour, I have, what is that, 12 times 3? I have 40 sessions with that. And if I pick my target IPs well, it may be a matter of time until I get a local admin with that. And then if I find antivirus gets in the way, I can attempt multiple payloads, do a bunch of different things to get it to work. So it turns out to be helpful for exploration and discovery, but also helpful for exploitation and privilege escalation too. And it's done tens or hundreds quite effectively for me so far.
So there's a difference relaying with like LMR poisoning from
Yeah, so LMNR or NBNS, you're telling them to connect to you. So if it comes into my IP, I don't know where to relay it. So you have to specify default targets. You can either specify one, and in the interface you can actually change that dynamically. Or you do the round robin where it goes to a big list of IPs. So.
SMB, V2, you ever going to try and support that?
Don't know. The V2 is very, very, very different. I've heard Egypt talking about it for Metasploit. They're grappling with that problem. Our solution is downgrade, and then all the tools work with it. But,
Downgrading works fine. I don't think we've had any
yeah.
problems with downgrading.
All we do, there's an SMB space 2.0 dialect, and we turn that into bogus. And nothing will ever negotiate SMB2. It'll always go back up to SMB1. So, all right. Cool. I think we're all set. Yeah, thanks.
All right, thanks, everyone.
We need to do it.